Okay, so in this video, we're going to look at statistics. And so in the other videos, you should have watched one video, either the graph and calculator video or how to use the stats calculator online video to show you how to use your time efficiently during this week. So if you forgot, this is more for if you're using a graph and calculator, but there's a calculator key right here. And it just kind of shows you what the symbols stand for. So the mean or the average is represented in your calculator by X with like a bar over it. The median is either, it's in your calculator, it's an MED, and then otherwise known as quartile 2. Q1 is quartile 1, Q3 is quartile 3. S with a little X below it is standard deviation, which we'll talk about later in this video. And then N is the sample size, or how many numbers that you have listed. Your minimum is your smallest number and your maximum is your biggest number. So this is just kind of a key that you have as you're working through these lessons, just to kind of make sure that you are gathering the correct numbers from your calculator. So that's just there if you need it. And I will also post a PDF of these notes into Schoology so you have that to reference at all times. Okay, so in the calculator video, you saw me show you how to type in the numbers for this example here. I'm going to actually skip this one and I'm going to move down for the sake of time. But it's the same thing and we already just calculated that, so that's why I'm not going to go through it again. But the new question I want to look at is the following set of data shows the number of contacts found in a person's cell phone based off a group of 8th graders. So it says find the measures of central tendency and the range for this data. So all the measures of central tendency are the mean, the median, and the mode. So those are all the things that you're just going to calculate off of this. So you've done this before and you can certainly do this by hand at any point, just the calculator just makes it faster. So the first thing I want to do anytime before I start, I want to make sure I list my numbers in order. So I'm going to go through it. I'm just going to list my numbers in order real quick. Okay, so I just listed all of my numbers in order and I kind of cross them out as I go. That's a tip to use. So the first thing I'm going to do is I'm going to calculate the median, which is just the average, which means all I'm going to do is add up all those numbers and then I'm going to divide by how many numbers I have. So I actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 total numbers. I'm just going to write that so I don't forget it. So I'm just going to take a minute and I'm going to add up those numbers and then I'm going to divide by the amount of numbers I have. So I got the mean to be, mean is also represented with X as a bar over it. It is 41.2. The median is the number in the middle. So this is really why we like you to put the numbers in order, so it's easier to tell the median or the middle number. So to find the median, I always start by crossing off numbers on each side. So I cross up the biggest, the smallest. I work from the outside in, 3, 4. And then I get to the middle and I have to find the middle of 40 and 42. So this is an easy example. The middle of 40 and 42 is 41. So that just means that, and you could do that by just finding the average of 40 and 42. So you could do 40 plus 42 and divide it by 2 because that's how many numbers there are, and you should get 41. So that's another way you can do it. But and then the mode is just a number that appears more frequently. So 53 is a number that appears twice. So that's another reason why you put it in order, just to kind of see that more easily. So that's how you do it. And you can do it by longhand at any point, but you're going to want to do it using your calculator. So you're going to plug all those numbers in using the feature that I told you. You're going to do stat edit. You're going to list all those numbers in as I taught you to do. And then you're going to just press stat, arrow over to calc. And then you're going to want to do one var stat. So it's the first option there. Okay, so a little reading here, but measures of central tendency give us numbers that describe the typical data value in a given data set, but they do not let us know how much variation there is in a data set. So two data sets can have the same mean, but look radically different depending on how the numbers are varied. So the data sets below have equal means, but differ in variation with the data set. Use your calculator to determine the interquartile range of each data set. The interquartile range is defined as the difference between the third quartile value and the first quartile value. So what I would like you to do is kind of practice what we talked about is in your calculators, I want you to enter this data, and then look at the third quartile and the first quartile in order to find the interquartile range, and then do the same with data 2. So I'm going to take a minute and I'm going to go put it in my graphing calculator, and then I'm going to list the first quartile and the second quartile, or the third quartile, and then we'll go from there. Okay, so I calculated using my calculator. This is where I pulled the information after I entered my data. If you're not sure how to do that, go back to the graphing calculator and watch that video. So I just, as a refresher, I just found the mean, which was 7 here. And then I found the median, which is also 7. And then quartile 1 was 4.5, and quartile 3 was 9.5. And so to find the interquartile range, all I'm going to do is take Q3 minus Q1. So it's going to be 9.5 minus 4.5, which will be 5. So the interquartile range of that top set of data is 5. And then the quartile 1 for the data set number 2 was 6, and quartile 3 was 8. So I'm just going to do 8 minus 6, which gives me 2. So the interquartile range of data set 2 is 2. And so the reason that's important is because the interquartile range gives a good measure of how spread out the data is. But the best measure of variation with the data set is standard deviation. The actual calculation of standard deviation is very complex, and I'll kind of explain how they do it, but we're really going to rely heavily on our calculators here, and this is more or less why we use the stats function in our graphing calculators instead of doing this by hand. So the first thing I want to say is, like, if you look, data set number 1 is got a bigger range of numbers. It goes from 3 all the way to 11. So the interquartile range naturally is bigger at 5. Where that just means there's more data sets, there's bigger numbers, or there's bigger range of numbers. And data set number 2, however, it only goes from 5 to 9, and the interquartile range is 2 there. So that means there's less range of numbers there. So that's really all standard deviation does, is show you like how spread out your data is, how close it is together. What's the range of your data? So the standard deviation of the data tells us on average how far a data point is away from the average or the mean of the data set. So the larger the standard deviation, the greater the variation within the data set. So just like data set number 1, the larger the standard deviation, the greater range of numbers. Just like data set number 2, interquartile range was lower, it's going to have a lower range of numbers. So when we're in a calculator, just as a reminder, you're going to look at the SX number. That there, the S stands for sample size, and we usually use that because usually we're only looking at a sample of data and not all of the data. So usually you just record some people's heights, not all people's heights. So it's really, we more care about the sample size standard deviation. So the SX you can find in your calculator. So a low standard deviation would be a number such as like 1.29, which would mean each data point is 1.29 numbers away from the average or the mean. So that means the data is very close to the mean. So like, for example, if your mean was 6, maybe your numbers are in a range of that mean. So they could be all the way up to, 8 maybe, or all the way down to around 4 or 5. So it's just kind of a way to gauge how spread out your data is. A higher standard deviation, such as 10.4, would mean each data point is about 10.4 numbers away from the mean. So your data is much more spread out. You have a larger variability of numbers. So again, you can use your calculator to find standard deviation. So it says, use your calculator to find the mean and the standard deviation for the following sets of data. So I'm going to take a minute, and in my calculator, I'm going to put in these numbers and look at the mean and the standard deviation. So when you do that, you should get a mean of 68.98, and you should get a standard deviation, or the SX is 1.59. So this is the important part. What this means is that each men about is 1.59 inches away from the average height, which is 68.98. And if you read the directions, it says calculate to the nearest hundredth. So that might be why your answer looks slightly different than mine if you did it on your own. But basically that just means that if I do 68.98 plus 1.59, I'll get 70.57. And then if I do 68.98 minus 1.59, I will get 67.39. So that's saying most of my data is going to lie between these numbers within one standard deviation of the mean, which just means like about this far away. So that's what that means about that data. So then in this next example, it says, for the following sets of data, calculate the mean and standard deviation, and then describe the mean and the standard deviation after calculating it. So the first thing, I'm just going to do one example in this video, and then I'll actually run through two examples. If you don't need another example, you can stop the video and start the practice. If you want to look for a couple more, just look at this. So the data set below gives the prices in dollars of cordless phones at an electronics store. So these are prices. So the first thing I'm going to do is I'm going to type them right in my calculator and find the mean and the mode, or mean and the standard deviation. Okay, so I just calculated the mean and the standard deviation. So 60.71 was the mean and 15.12 was the standard deviation. So what that means about the data is the price of a cordless phone is about $15.12 away from the average cost, which is 60.71. Okay, so that's what it just means in terms of if you're talking it out. So I'm going to do one more example. It says the data set below gives the number of home runs for the 10 batters who hit the most home runs during the 2005 Major League Baseball regular season. So again, I'm just going to pause the video, type the data in my calculator, and look for the mean and the standard deviation. Okay, so I got the mean, which was 44, and standard deviation was 4.03. So that means the amount the batters who hit the most home runs, the number of home runs are about 4.03 hits away from the average of 44 hits, home runs. So that means at any given point, so let's say I look at the fifth batter, he's probably going to be within 4.03 home runs from 44 home runs, if that makes sense. So it's just kind of a way to see. So like, for example, the data up here is way more variability. So like there's way more of a range of numbers here. Their numbers are way more spread out. Whereas in the second example, the numbers are way closer together because there's a smaller standard deviation. So the standard deviation just kind of tells you where most of your data lies and how far away it is from the average. So those are two examples. And so we went over standard deviation, central tendencies. I will make a PDF of this and post these notes into Schoology so you have them to reference at any point.